everyone, and welcome to Data Product's first installment of Data Science Simplified. This is a webinar series where we present a new data science topic each week. My name is Dr. Mechie Nkengla, and I am the founder and principal data strategist of Data Products. This week's topic is AI versus ML versus DL. Or in other words, what is the difference between artificial intelligence, machine learning, and deep learning? Let's start with artificial intelligence or AI. This is by far the most popular of the three, and the one that has captured Hollywood's imagination. Let me guess, you're picturing Harrison Ford facing off against replicas of humans in Blade Runner. No? Maybe Neo fighting off sentient bots in The Matrix? Well, we're still pretty far off from that even in 2020. First, a little backstory. The term artificial intelligence was first coined by John McCarthy, a professor of computer science at Stanford University. He organized a conference in 1956 where researchers, focusing on a wide range of topics, from language simulation, neural nets, complexity theory, and others, were invited to discuss a new subject, artificial intelligence. During the conference, they worked to develop ideas around thinking machines. Fast forward to today, where we tend to focus on AI as a subfield of computer science and how machines can imitate human intelligence in a variety of ways. The goal is to develop computer systems that can complete tasks such as make decisions, perceive objects visually, speech recognition, tasks that usually require, you guessed it, human intelligence. This is different from machine learning or ML, which can be used within artificial intelligence. Basically, machine learning describes teaching computers to learn in the same way humans do by interpreting data, classifying it, and making adjustments based on successes and failures. None of this is possible without data, and lots of it. Back in the 1950s, when Arthur Samuel was doing the first serious research on machine learning at IBM, he tried teaching machines to play checkers. One reason he chose checkers was that there were volumes upon volumes of annotated checkered games available where experts had identified the good moves from the bad ones. Samuel's program used these guides to checkers to teach the computer the necessary criteria for identifying what were the best moves. Today's computers are far more sophisticated now that we're living in an age of big data. Imagine you want to teach a computer to be able to identify whether or not there is a cat in a photograph. After feeding it hundreds of thousands of pictures of cats of all sizes and breeds, it would eventually have enough information to be able to identify a cat with fairly high accuracy, unless, of course, it's one of those hairless Sphinx cats. I have some issues with that one as well. The act of feeding information to a computer system in order to learn is what data scientists mean when they talk about learning. Now, there are two types of machine learning algorithms, supervised and unsupervised. Supervised machine learning algorithms can apply what has already been learned to new data to predict future events. It begins with a known training data set, then produce inferred functions to make predictions. This is different from unsupervised machine learning algorithms, which are used when the information that is used to train is neither classified nor labeled. In that version, the system explores the data and can make inferences from the data set to describe hidden structures within the unlabeled data. Are you still with me? Because we've finally arrived at deep learning or DL. This gets a little less press, but is nevertheless responsible for some amazing modern breakthroughs. We just talked about how machine learning involves the computer receiving large quantities of data to develop training data sets. Well, this is the other half of that picture. Beyond just taking in that data, machines must be able to process it as well in order to learn. Here's how that happens. Researchers found over years that the most effective framework for machines to learn is the artificial neural network. Rather like human brains, this network functions around connected neurons that can execute data-related tasks. This could be something like recognizing a picture of a cat or failing to recognize a picture of a cat. The neurons then pass these results to adjacent neurons, which process it further. The flexible network continues to change and adapt based on the data passing through it, and are thereby able to deal with new information much more effectively. This describes learning again. Now, deep learning is really just machine learning that is derived from deep neural nets. These are created by layering networks upon networks that pass the information downwards. And there you have it. That is AL versus ML versus DL in a nutshell. For more data science insights and future installments of Data Science Simplified, just subscribe to our YouTube channel, Data Products. You can also follow us on Facebook at Data Products LLC or on Twitter at Data Products. Well, stay safe and see you next time. Bye-bye.